Hi, I'm Warren Allgaier, 9 Victor 1 Tango Delta in Singapore. Today I want to show you how I've set up my RXTX using voice shaper software to improve the efficiency and the punch of the sideband signal out of the RXTX. In a previous tutorial we set up voice shaper software, so I won't go into that now. We will be using the settings that we used in that previous tutorial. With one exception, I've broadened out the lower end a little bit so we get a little bit more pleasing signal. The objective of the tutorial was to improve the punch of voice shaper, and in this case what I'm going for is three things. Optimal sound that you can get through a 2.4 kilohertz baseband, so a nice even sound across the entire spectrum. I want to optimize the level of the sound, so we're using some compression, as we explained in the earlier video, using some compression to raise the average level, and I want to, as much as possible, or get as close as possible to the 1 watt output specification of the RXTX without, and this is key, without causing splatter into an adjacent channel. So, in order to do that, I've got a setup here, and let me just run through real quick how I've set this up so you'll understand what we're doing. First, we're going to use the voice shaper software, which we demonstrated previously, set up in the way I've just described. And then I have a homemade peak reading logarithmic VU meter. It's not a VU meter specifically because a broadcast VU meter has very particular ballistics on how fast the meter will come up and how quickly it will decay. Mine is logarithmic, so it measures in dB, but it's a peak reading meter, and I'm using that to verify the levels out of the voice shaper software and PC that go into the RXTX. Okay, so then we're using over here, we're using a PC, and we're using a 40-30-20 build of the RXTX. By the way, this 40-30-20 build, just for anybody who's interested, also has been modified to have an external reference input, so I can actually drive it from my GPS and have a precision frequency source, but that's probably the material for another tutorial. So we got the HDSDR and the RXTX. Here I've got a filter box that we're using to put in the low-pass filter because we're doing these tests on 40 meters, and those of you who've built an RXTX know that the second harmonic on 40 meters is not within spec. So we need an external low-pass filter, which is in this box. But this box also provides me with the capability to attach a scope so I can read the RF voltage. And so, that's the next thing we're going to use. We've got an oscilloscope here that is set up to read the peak PEP voltage across a 50 ohm load. And that will tell us what the real PEP power that it is that we're generating. And remember, our goal is to get to 1 watt as much as possible. Back here I've got a 60 dB pad that also serves as a dummy load for the high power equipment when I use it. The output of that pad then fits a splitter and goes to an RX2, a Softrock RX2, which is my general purpose monitoring receiver. The output of that is displayed on a second iteration, a second PC and an iteration of HDSDR. And that's where we will look and assure that we're not splattering into an adjacent conversation. And then finally, we've got a spectrum analyzer up here which serves two purposes. One is its confirmation on the peak levels that we're generating out of the system. And secondly, it lets us keep an eye on any harmonics or spheres that we're generating. Okay, so we're going to do three cases here. We're going to set up the system first with an uncorrected microphone. This is my famous $12 Radio Shack microphone. And we will set it up so that we get 1 watt, or as close to it as we can, PEP, without adjacent channel interference. And then we'll listen to it. And so that's an uncorrected microphone. Test case number 2 is we will roll in the equalization that we set up previously in the previous tutorial. And that equalization will flatten the response across the sideband passband, and greatly improve the sound, as you'll hear. All right, and then test case number 3 is we're going to add to that, where we flattened the sound, we're going to add to that clipping, so we're going to reduce the overall peaks, and we're going to add compression, where we bring up and compress the intelligence that's in the voice. And so at that case, we will have what I consider to be the optimum sound. We'll have as close to 1 watt as we can get without splattering. We'll have a very high average power level, and we will have a nice even frequency response across the entire passband. So with that, let's go. We're going to reset it so that there is no equalization and there's no compression, no clipping. All right, we've got that. We're going to take a look over at the VU meter, and we can see that as the loop is playing, we're peaking right at green, which is 0 dBm. It's just a reference level coming out of there, but every time we'll check that and make sure that that's exactly the same in all 3 scenarios. Okay, we go over to HDSVR, and we're going to put HDSVR in transmit. And I'm going to turn down the voice. Well, actually, I'm going to turn down the voice for the moment. And we go up to the received version of HDSVR, and we can see the waterfall. We can see what's happening with the waterfall. You see a little bit of trace over here, where I've got on the right side just a little bit of upper sideband splatter. Now I'm going to go to HDSVR transmit, and I'm going to grab the mic gain control, and we're going to take a look at the mic gain control as I increase it. We're going to increase it, and now you can see dramatic splatter. Those are the signals going out either side to the right and left of that waterfall, and that's what we want to avoid. So we're going to back that mic gain down until it's nice and clean. About, you know, I'm fudging it a little bit because I want to get some good power out of it. Everybody does that, I think. Okay, so we're going to set it about there, and it looks like I'm getting. We check on the scope. You can see the envelope. It looks nice and clean, and we're getting 16, 18, 20. We're getting about peaks at about 1 watt, so that looks pretty good. Now we go over to the spectrum analyzer. We take a look, and it is peaking right at -30. Peaks are touching -30. Okay, so we've got a signal that is not splattering. It's got good envelope, and it's got good spurious response. So what's it sound like? Let's take a look.
1, 2, 3. This is Band Victor 1 Tango Delta Singapore. Test 1, 2, 3. This is Band Victor 1 Tango Delta Singapore. Test 1, 2, 3.
Okay, so what we've got there is a signal that doesn't sound good at all. But what I'm pretty sure is that it is a function of this microphone, because we're not overmodulating, and we're making good peak power. But that signal is not one I'd be proud of, and that's exactly why we're here, is to fix that. Okay, so let's go to case number 2, readjust, and then take a listen. So we go back to Voice Shaper, and I am going to put in equalization on that microphone, and you can see that I've adjusted this a bit from the tutorial, as I said, to bring up a better lower end. So now we're equalizing that microphone, and we'll take a look at the output level. Looks like we could use just a bit of help on the output level. Well, let's take a look, and I'm gonna, okay, let's make that green. Good. And let's go to HDSVR. Take a look there. HDSVR in both cases, on receive and on transmit. And on transmit, I'm going to grab the mic gain control again, and I'm going to bring it up until I see some objectionable splatter about there. And I'm going to back it down until I get a nice clean waterfall trace. Okay, let's confirm. We take a look at the scope. We're peaking 1 watt. I see 21 in there occasionally on the peak reading. And on the spectrum analyzer, kind of confirms it. We're about 1 watt. So what we've done now is we've equalized the response of the microphone, And we're still transmitting, so let's take a listen, see what that sounds like.
Singapore, test 1, 2, 3. This is 9 Victor 1 Tango
Wow.
Delta Singapore, test 1, 2, 3.
That's not
This is
bad.
9 Victor 1 Tango Delta Singapore, test 1, 2, 3.
Okay, that's pretty good. I'd be happy with that. I mean, actually, I'd put that on the air, no problem. We can make it a little bit better. So we're going to go to test case number 3. We go back to voice shaper. We put in the gating, noise gating, and compression and clip levels that we set during the setup session. And now I'm going to go, once again, same drill, back to HD SDR in both cases, adjust the mic gain for a nice clean trace without objectionable modulation into the adjacent channel. And that's probably about right there. Okay, so what do we have? Well, looks like on the scope, looks like our peaks are down a bit. I'm seeing 17, 18, I'm not seeing 21s, and that's a function of the clipper. The clipper is cutting off those high-level peaks. So our absolute peak reading is going to be a little bit lower, but our average power is going to be much higher. And if we take a look at the spectrum analyzer, it sort of confirms it. The peak isn't going up as high. Spurious is still good. So let's take a listen to that, see what that sounds like.
Test 1, 2, 3. This is 9 Victor 1 Tango Delta Singapore, test 1, 2, 3. This is 9 Victor 1 Tango Delta Singapore, test 1, 2, 3.
Well, good or bad, that's a judgment you have to make. Personally, I like the signal, the sound of the signal with equalization only and without the clipping and compression. If you were in a strong signal situation, that would probably be a better signal to use because it actually sounds better. In QRM, in weak signal situations and situations where you're fighting to get through a pileup or just get through noise with 1 watt, this compressed signal is going to have better penetrating power and it's going to sound better, as we demonstrated when we set it up in voice shaper. So just to review, let's run through the 3 scenarios and you can listen to them. Here is unequalized and uncompressed microphone.
This is 9 Victor 1 Tango Delta Singapore, test 1, 2, 3. This is 9 Victor 1 Tango Delta Singapore, test 1, 2, 3.
Now I'm going to kick in the equalization.
Tango Delta Singapore, test 1, 2, 3. This is 9 Victor 1 Tango Delta Singapore, test 1, 2, 3.
And now we're going to add compression and clipping.
Singapore, test 1, 2, 3. This is 9 Victor 1 Tango Delta Singapore, test 1, 2, 3. This is 9 Victor 1 Tango Delta Singapore, test 1, 2, 3.
And I'm going to back down to end this with the one that I prefer, and that's no clipping and no compression. Of course, as we demonstrated before, you can change the level of clipping and compression, the degree. I just wanted to use the same settings that we arrived at during voice shaper setup session. So that's it. That's optimizing the RXTX. What we accomplished here was we set the passband of our input audio signal so it was nice and flat across 2.4 kilohertz. We raised the level, the average level of that, and we did that getting 1 watt out of the RXTX and keeping an eye on the adjacent channels to make sure that we weren't splattering over into it. So it can be done, and we can get really nice sounding single sideband out of an RXTX, a cheap microphone, and a piece of free software. Thanks for listening. This is 9V1TD, 9 Victor 1 Tango Delta, Singapore, Warren Algar. Have a great day.